Alright, so this first video here is how to solve exponential equations using logs. So what I have to do first is I have to recognize this base with the exponent is all together, and I want to isolate that. So I'm going to add 7 to both sides. So I have 4 to the 2x plus 3 equals 17. Well, a couple topics ago we got common bases, but I can't get a common base between a 4 and a 17, so this is where I have to take the logs. So we've been talking that the only thing that will undo this, that will remove this, is to really apply some log rules, is really to take the log of both sides here. So I'm not putting it in log form, I'm going to take the log of each side. And if you remember, when you had something like x squared, that became 2 log of x when we had log of x squared. So that 2 went in the front, that power. So I'm going to take this whole entire power, 2x plus 3, and I'm going to multiply the log of 4. But if I do that on the left side, then I have to do it on the right side also. So I took the log of this side. When I take the log, I'm applying log rules, and I take the log of 17. Now from here, there's a couple of ways that you can do this. These are base 10, so your calculator will understand base 10. You could go through and distribute here. I'm not going to. I'm going to keep this as 2x plus 3 equals the log of 17 over the log of 4, which is a value. All right. And you can either work in your calculator and show the decimals, or you can continue to isolate here. So I could subtract the 3 over, so log of 17 over log of 4. I'm going to subtract the 3 over. And then again, if I want to get x by itself, I could take all of this. And I could divide by 2. And the good thing about your Inspire is that it will do that. So if I have my control division sign and I take the log, again, it understands base 10, the log of 17 over the log of 4. Whoops. Log of 17, log of 4. They have common bases. You don't have to put that in there. Just can't see anything. 4. I'm dividing everything by 2, but in this numerator, I'm also subtracting 3. So Inspire works to do that. And I can get this value here. And if I don't want to, I can take the log of 17. I can divide it by the log of 4. And I can find out what that value is. Alright. And then I can subtract 3. And then I can divide by 2. Just depends on really how you want to do that operation. It does say round to the nearest thousandth, so that's 3 decimal places. So that would give me x equals negative 0.478. And I can take that and I can put it into my original equation. So I have 4 to the 2 times my answer minus 3, sorry, plus 3. And if I take away 7, that's going to give me 10. And I don't need to do it, but there you go. So that answer should check. And the domain of these exponential functions is all real numbers. So your values should check here. All right, so there's that. This one here works the same. I'm going to isolate. This is actually my base. E to the 4x is actually my base. So I'm going to add 8. So 3 times e to the 4x equals 11 plus 8, which is 19. All right, I divide by 3. E to the 4x equals 19 divided by 3. It's not a whole number, so just leave it. All right, but now again, to release this x, to release the x from the exponent, I take the log of both sides. So I have 4x times the natural log of e equals the natural log of 19 divided by 3. I have to take the log of both sides in order to release that exponent. Now the natural log of e, that's actually equal to 1. The natural log of e, a hard fact that you do need to know is that the natural log of e is equal to 1. E to the first power gives you e. So this is really gone. So now I have 4 times x equals the natural log of this value here. So if I want to get x by itself, I'm taking the natural log of 19 thirds and then I'm going to divide it by 4. So if I again go back to my calculator there, here's my calculator. I'm going to do the natural log this time. The natural log of 19 thirds, get out of the parenthesis, and divide by 4. And your calculator will do that. All right. So what do we got? 0.461. So the value here, x, is approximately 0.461. You could take that and you can substitute it back into the equation to check it. So I really shouldn't have to give an answer key because you can take every single one of these, I didn't mean that, and do 3 times e to the, deep breaths, sorry, I don't know why I keep doing that. 3 times e to the, what is it, 4 times my answer. 4 times my answer, minus 8, so get out of that, subtract 8, and I get 11. So you could check all of these answers, you just gotta keep that decimal in there so that you're holding that there. Okay, that's how to just solve exponential. When I give you an exponential equation, you're taking the log of both sides. It's really important that you understand that language there. I'm taking the log, and when I'm applying that log, I'm taking the log. That's where that power rule came into play. And if I take the log on one side, I have to take the log on the other side. Just like if I add on one side, I add 7 on this side, I add 7 on that side also. Okay, so that's examples 1 and 2.